Why do heat exchangers crack from thermal stress? Imagine a metal tube in a heat exchanger suddenly cracking just because of a temperature change. That might seem surprising, but it all comes down to how materials respond to heat. When a heat exchanger operates, it transfers heat between two fluids, often at very different temperatures. This process causes different parts of the device to heat up or cool down at different rates. Metals expand when heated and contract when cooled, but not all parts do this equally. This uneven expansion is called differential thermal expansion. For example, the tubes that carry hot fluids may expand more quickly than the surrounding shell. When this happens, mechanical stresses build up at the points where these parts connect or bend. If these stresses become too strong, the metal can crack. Over time, with repeated heating and cooling, these small cracks grow larger. This process is known as thermal fatigue. Cracks often start around areas that experience the biggest temperature differences, like U-bend tubes. These areas bend and flex a lot as they heat and cool, making them more prone to cracking. The cracks usually run outward from the center of the tube, and if they grow unchecked, they can cause the tube to break completely. Another factor that makes cracking more likely is residual stress. These are stresses locked into the metal during manufacturing, such as from welding or cold working. When the heat exchanger heats up during operation, these residual stresses add to the thermal stresses, increasing the chance of cracks forming. Corrosion can also play a role. If the heat exchanger is in a harsh environment with chemicals or geothermal water, it can suffer from stress corrosion cracking. This occurs when tensile stresses and corrosive agents work together to weaken the metal along grain boundaries or through the grains themselves. Cracks caused by this process can grow quickly and cause serious damage. Cracking from thermal stress can lead to leaks, which reduce the heat transfer efficiency and can cause the heat exchanger to fail. Engineers use tools like finite element analysis to predict where stresses might be highest. They also select better materials and improve design to prevent these issues. Regular maintenance and inspections help catch problems early before cracks become serious. In summary, heat exchangers crack from thermal stress because temperature differences cause uneven expansion, creating internal stresses that can break the metal. Residual stresses from manufacturing and corrosive environments can make cracks worse. Understanding these factors helps in designing more durable heat exchangers and keeping them running smoothly.